Okay, walk at Tailwind at 6.3, fitting square root functions to data assignment tutorial. Question number 1. Body mass index BMI is measured used to determine healthy body mass based on a person's height. BMI is calculated by dividing a person's mass in kilograms by the square of his or her height in meters. The median BMI measure for a group of boys are given in the chart. All right. Now, step 1, graphing is pretty straightforward. Just basically graph the points on the graph. That should be pretty easy. All right. Now, step 2, find the estimated initial point, which is the vertex. What that is this point right here, which is the first point in the table. So this is your vertex. Okay, so your vertex is 15.4, comma 12. Step 3, find the second point for reference. The second point of reference is 16.2, comma 15. Now I want to point out that when you're doing assignment, your second point, they want the 1, 2, 3, 4, fourth point in the table. Okay. All right. So there's your vertex and the second point. Now, question number 1 continued. Step 4, solve for the estimated square root function. Okay. The standard equation for a square root function is y equals a square root of x minus h plus k, where the vertex is parentheses h comma k. Okay. Now, before I do this, I just want to show you how you can use Desmos. I'm going to only show you on one question how you can use Desmos to get this equation from the table. Okay. So we're going to go to Desmos square root regression. Okay, so we're going to click right here. All right, we don't want this. We don't want this. We're going to go to the third column. We're going to press the backspace and delete that. We're going to go to this column. We're going to backspace and delete that. Okay, so then we now need to delete these values. Okay, and delete these values. Okay. Oh, let me go back to there. Now let's put in the values from the table. So 15.4, 15.5, 15.8, 16.2, 16.6, 12, 13, 14, 15, 16. Okay. Now, we don't want this one because that's linear. We don't want this form. This you should recognize from the problem. And so here, all you'd have to do is plug this number in for A, this number in for B, this number in for H, this number in for K, and then you'll have your equation. Okay. All right. So that's using Desmos, but let's go back to using the algebraic method. Okay. All right. Let me refocus the camera. All right. So H and K come from your vertex. Okay. So this is your H value. So H, and this is your K value. Okay. So 15.4, 12. Okay. Now your X and Y value, this is your X, this is your Y. Okay. So X is 16.2 and Y is 15. All right. So now we solve for A. So we plug those numbers in. So Y is 15 equals A we're trying to find times the square root of X is 16.2 minus H, which is 15.4, and then plus k, which is 12. Okay, so we need to know what 16.2 minus 15.4 is. We can just use a simple calculator for that. So 16.2 minus 15.4 is 0.8. So 15 equals a times the square root of 0.8 plus 12. Now we're going to subtract 12 from both sides. So 15 minus 12 is 3. So 3 equals a times the square root of 0.8. Now we're going to divide both sides by the square root of 0.8. Well, this divided by itself is 1. So a equals, and we can use Desmos for that one. So let me go to desmos.com. We're going to go to scientific calculator. So if I press the divide symbol first, I can have the fraction immediately. 3 square root of 0.8. And then I believe they want the answers in, I don't think it says. So we'll just go 2 decimal places. Okay, so 3.35. Okay, so A equals 3.35. All right. So the equation is 3.35 times the square root of x minus the h value, which is 15.4, and then plus 12. And we need to use this so we're clear on what's underneath the square root. The plus 12 should be on the outside of the square root. All right, let's take a look at question 2. All right. Question 2. All right. Question 2, really straightforward and simple. It says indicate the domain and range of the estimated fit function. All right. So the domain starts at the vertex. Now you can see that it's greater than, okay, and it's the x value from the domain. So domain here is x greater than or equal to 15.4. And the range is the y value of the vertex, and you can see its graph is greater than, so the range is b greater than or equal to 10. Okay. All right, go ahead and finish up question 2. All right, question 3. Thomas opens a new boat dealership in the beginning of 2008. And sees his sales grow every year. The data represents a year T and the number of boats sold each year. Okay. Now, use 2008, 35 as the initial point and 2013, 55 as the second point on the curve. Find an equation for the estimated square root function. All right, so graphing real simple. You just graph the points, use either Desmos or some grid paper, but finding the graph should be very straightforward. All right, step 2. Find the estimated initial point which is the vertex. Well, the vertex is 2008, 35, which you can see from the table, which is the first point. And in this problem, they want to use the 1, 2, 3, 4, 5, 6 point down, okay, as their second point. So the second point of reference is 2013, 55. Okay. All right. All right. So step 4, okay, solve the estimated square root function. Now I've shown you how to use Desmos, but now from this point on in the tutorial video, I'm just going to show you how to algebraically find the equation. Okay, now H is 2008. K is 35. Okay, and that comes back to the table. This is your h. This is your k value. Okay, this is your x. This is your y. All right. So 2013 is your x value, and let me go back to my page. 55 is your y value. Okay, now we solve for a. So y is 55 equals a times the square root of x, which is 2013, minus h, which is 2008, plus k, which is 35. All right, so in this case, let's go ahead and subtract the 35 first from both sides. So 55 minus 35 is 20 equals a times the square root of 2013 minus 2008. I think that is 5, but let's just double check. It's 5, yep. So square root of 5. So now we divide both sides by the square root of 5. All right, that divides and becomes 1. So a equals 20 divided by square root of 5. So let's go back to Desmos. So 20 divided by the square root of 5 is 8.94. All right, so a is 8.94. All right, so the equation is 8.94 times the square root of x minus 2008 plus 35. All right. Let me just make it very clear what's underneath the square root. All right. Let's move on to the next question. All right, question 4. An object traveling at a certain speed has a kinetic energy of 30 kJ. Model the speed of the object based on its kinetic energy given in the table below. Okay. All right. Use 30, 0 as the initial point, which is the vertex, and 3,655, 60.03 as a second point on the curve. Find the equation for the estimated square root function. Round the value of a to the nearest thousandth. Enter the domain and range of the function as inequality. All right. So this is your h. This is your k. This is your x. This is your y. All right. So now let's go to step 4. Okay. Oh, I'm sorry. No, question number 4. Continued step 1. Solve for the estimated square root function. The standard equation for a square root function is y equals a times the square root of x minus h plus k, where the vertex is h comma k. So h, which we know, is 30. K is 0. X is 3,655. Y is 60.03. Okay. Step 2, solve for a. So y is 60.03 equals a, we don't know, times the square root of x, which is 3,655, minus h, which is 30, plus k, which is 0. Okay, so real simple, we don't need to do anything with the plus 0. Now we need to find out what's underneath the square root. So that's 60.03 0.03 equals a times the square root. Well, this is simple. Really, you're subtracting 3,655 minus 30, but really you're just subtracting the 55 minus 30, which is 25, so that's 3,625. Okay, we're going to divide both sides by the square root. Okay, so now this divides and becomes 1, so then a equals, all right, let's go ahead and put that in Desmos. So 60.03, and then 3,625. All right, which is, let's round that one to 3 decimal places. So it's 0.997. All right. All right, so A is 0.997. All right, so the equation is 0.997 times the square root of x, which is 3,655. Oh, whoa, almost made a mistake. You don't actually plug the x value in because it's not an equation if you don't have the x and y. So I apologize. That was almost a mistake. X minus h, which is 30, and then plus 0. I don't think in HRW you're going to have to put the plus 0. So my guess is, or I should say my assumption is that this is what you're going to put in as your answer. Okay. All right. Step 3. The domain is restricted to values such that x minus 30 is a non-negative, so the domain of the function is x greater than or equal to 30. Step 4. The range is restricted to real numbers greater than 0. Since x is greater than or equal to 0, so the range of the function is y greater than or equal to 0. All right, let's go and look at the next question. All right. Question 5. Indicate the domain and range. The domain and range is very simple. The domain is greater than or equal to 0 because it's going to the right, and the range is y greater than or equal to because it's going up. So then the domain is based on the x value of the vertex. So the domain is x greater than or equal to 70, and the range is y greater than or equal to 0. Okay. All right. So let's go on to the next question. All right. Thomas opens a new boat dealership at the beginning of 2008 and sees his sales grow every year. The graph shows an estimated square root function, blue, and a square root function derived using quadratic regression, red. Okay. Predict the expected year when the boat sales will reach 65 and compare the result of the two models. Complete the explanation. Okay. So real simple, what you're going to do is draw a horizontal line at 65 right here. Okay. And then you look where that horizontal line intersects the two graphs. Okay. Now, you can see here that it intersects the blue line here. So then you draw a line vertical down, and you can see that it's at 2018. Okay, so drawing a horizontal line at s equals 65, the given estimate of 2018 for the estimated model, and you can see here that the horizontal line intersects the red line here, so you draw a vertical line down, and you can see that it's 2016 for a regression model. The regression model predicts that 65 boat sales will be reached sooner because it rises faster than the estimated model. All right, let's take a look at the next question. All right. Question number 7. Indicate the domain and range. Again, very simple. Domain is greater than or equal to because it's going to the right, and range is greater than or equal to because it's going up. Now, the domain value is the x value of the vertex, which is 2, and the range value is the y value of the vertex, which is 7.3. So the domain is x greater than or equal to 2, and the range is y greater than or equal to 7.3. All right, go and finish up question 7. All right, question 8. Indicate the domain and range of the estimated fit function. Okay, again, now this one's different in that the range still greater than or equal to 0, that's the same, but now the graph is going down, so the range is y less than or equal to. Okay, but the domain value is the x value of the vertex, and the range value is the y value of the vertex. So the domain is x greater than or equal to -3, and the range is y less than or equal to 2.4. All right, let's take a look at the next question. All right, question 9. Okay, the body mass index, BMI, is a measure used to determine healthy body mass based on a person's height. BMI is calculated by dividing a person's mass in kilograms by the square of his or her height in meters. The horizontal axis is the BMI and the vertical axis is the age. Solve the equation graphically using graphs shown below. Complete the explanation to compare the results. Okay. Now, it says find the expected BMI for child at age 8.5. So 8.5 is right here. So we're going to draw a vertical line at 8.5. And you look for when it intersects the line. Now, well, that's at this point right here. You can see that it intersects both graphs at the same point. So you draw a vertical line down, and you can see the value is 16. Okay, so the expected BMI for a child at age 8.5 for the estimated function is 16. The expected BMI for a child at age 8.5 for the regression function is 16. There is not, and see, you can see here, there is not a difference in the models at the BMI because they both intersect at the same point. Okay. Let's take a look at the next question. All right, question 10. Okay, an object traveling at a certain speed has a kinetic energy of 30 kg. Solve the equation graphically using the graph shown below. Complete the explanation to compare the results. The horizontal axis is energy in kg, and the vertical axis is the speed of the object in meters per second. Okay, now it says find the kinetic energy of an object traveling at 25 meters per second above the initial speed. So again, we draw a horizontal line at 25. Okay, and we look for where they intersect. Okay, well, they intersect the blue line right here. So we draw a vertical line down. Okay, and so we can say the expected kinetic energy of the object for the estimated function is 675. And now you can see that it intersects the red line, which is the regression here. So we draw a vertical line down. And we can say that the expected kinetic energy of the regression function is 775. The regression model produces a greater value because the regression model is below the estimated model when the object is traveling at 25 meters per second. All right, go ahead and finish up question 10. All right, question 11. Okay, solve the equation graphically using the graph shown below. Complete the explanation to compare the results. Round your answer to the nearest 10. Okay, it says find x when y equals -2. So we draw a horizontal line at y equals -2. And we look for where they intersect. Okay, now you can see here that it intersects the blue line right here. So we draw a vertical line down. So we say that when y equals -2, x is 2.6 for the estimated function. Okay, now we see where it hits the red line, which is right here. Okay, so we say when y equals -2, x is 3.7 for the regression function. The regression model produces a greater x value because the regression model is above the estimate model at y equals -2. All right, this should help you finish up your assignment. So go ahead and finish up your assignment and have a wonderful Wildcat day.